Hello everyone. So welcome to the session on Francis turbine. This is our second type of turbine. In earlier session we have already seen the working and the construction of Pelton turbine. So now we move on to the second type, that is the Francis turbine. This is also coming in module 5 of the course Fluid Mechanics and Machinery. So Francis turbine uses both kinetic and potential energy to produce power. Now Francis turbine is a mixed flow turbine. So what do you mean by mixed flow turbine? We will see later. And the specialty of Francis turbine is that it can work efficiently in head as low as 50 meter to 400 meter, and also wide range of flow rate as low as 10 meter cube per second to 700 meter cube per second. So this is known as a mixed flow turbine, and it is widely used in hydropower plants. So this is a figure showing the essential parts of a Francis turbine. Here also you have guide vanes, runner vanes, impeller, stay vanes, etc. Now we will look into each one of these parts. Before moving to the parts, the working principle of the Francis turbine, or the design of the Francis turbine, is such that one portion of the blade creates pressure difference between the opposite face of the blade when the water flows through it, and the other portion of the blade, it uses the impulsive force of the water hitting it. So you have two forces, one is the pressure difference and the other is the impulsive force. So this combined action of pressure difference and impulsive force generates enough power to get the turbine moving at required speed. This is the primary working principle of a Francis turbine. Thus, there would be an increase, there would be a decrease in kinetic and potential energy at the exit, but when compared to the entrance, it will be having enough power to start the rotation of the turbine. But when it reaches the exit, the kinetic energy and the potential energy would be decreased. So this is the working principle of a Francis turbine. Second one is stay vanes. We already know what is a guide vane. You can see in the figure what is a stay vane and what is a guide vane. The stay vane will remain, as the name indicates, it will remain on the stationary, it will remain stationary on the position, that is it will be staying there itself, and the function is to reduce the swirling of water due to radial flow as it enters the runner blades, thus making the turbine more efficient, whereas guide vanes can adjust its angle as and when it is required, which is known as angle of attack. We will see that in the next slide, that guide vanes. Here water passes through the stay vanes and then it reaches into the guide vanes to before it enter into the runner blades. So guide vanes, unlike stay vanes, can change their angle and control the angle of attack to the runner blades, making them more efficient. And also they can regulate the flow of water depending upon the power required, power output of a turbine. Now the next part is runner blades. Design of runner blade, it decides how well a turbine is going to perform. This is a mixed flow turbine. So mixed flow turbine, the runner blades are divided into two parts. The upper part of the blade used for the reaction force of water through flowing through it, and the lower half in the shape of a small bucket using the impulse action of the water flowing through it. This we have already seen in the working principle. So the two forces, that is the pressure difference and the impulsive force, makes the runner to rotate. And the last part is obviously draft tube. Draft tube, it's a tube with its area of cross section increasing along its length, and so that the main function is that water coming out of the runner blades is at considerably low pressure, so expanding the cross section helps to recover its pressure and it flows to the tail race. Now, working principle: water enters the turbine through spiral casing and starts entering the runner blades, passing through the stay vanes and then through the guide vanes. Then it moves through the casing is of decreasing cross-sectional area and it is a spiral shape. So the pressure energy of water would remain uniform through its length, as a portion of water is also entering the runner blades. So this would reduce its flow through the length of the casing. Now, as we already have told, stay vanes will be stationary at their place, and it does the function of removing the swirls from the water, and tries to make the flow of water more linear. It makes it more linear and avoids the turbulence um, that will be created. Angle of guide vanes. The guide vanes are not stationary, they can move and the angle can be adjusted. The angle of guide vane decides the angle of attack of water at the runner blades, which makes sure the output of the turbine. So the guide vanes also controls the flow rate of water into the runner blades, just acting according to the load of the turbine. And the runner blades are stationary, cannot pitch or change their angle. So it's all about the guide vanes which controls the power output of the turbine. And again, we know that the runner blades, we have already seen it is designed so that it has got two parts, upper part and lower part. The upper part has pressure difference, the lower part has the impulsive force, and these two makes the runner to rotate. That is being explained in this slide. And the water coming out of the runner blades would lack kinetic energy and pressure energy. So in order to overcome these, we put a draft tube to recover its pressure before it reaches the tail race. But we still recover the pressure to that extent that we can stop air to enter into runner housing, thus causing cavitation. So cavitation is another big problem in this turbines. Now the application, it is used to generate electricity. Mixed flow turbine is also used in irrigation purpose, pumping sets pump water from the ground for irrigation. It is also used for a wide range of water head and flow rate. It is the most efficient hydro turbine we have till date.